let's kind of translate that. What does all that say? First part here, f of x is greater than or equal to h of x, but less than or equal to g of x. So basically, f of x is between the other two functions. All right, so that's between h of x and g of x. Right, on some interval. So it doesn't necessarily have to happen for the whole domain of all these functions, but at least on a portion of the domain where c is. All right, so at least one little part, f of x is in between the other two all the time. Or it could be equal to both of them or one of them, but it never like is bigger than g of x, never smaller than h of x. So it's always kind of squeezed in. So we can see that in this graph, right? F of x is the one kind of in the middle. Well, it says that if the limit of h of x and the limit of g of x as x approaches c is L, so like the graph's a little bit off, but they should all kind of be coming together here. If the limit of these two outside functions are both L, then it means that the limit of the one in the middle also has to be L. Right? If it's in between those all the time, or equal to, and both of these have the same limit at this point, well, the limit of the one in the middle has to be the same. Right, so that's what all that that squeeze theorem is trying to say. And we're going to kind of show how that helps us. Let's look at this example down here. It says that cosine of u is less than or equal to sine of u over u, which is less than or equal to 1. On the interval from negative pi over 2 to pi over 2. Let's go ahead and take a look at that graph. So I've already got it in here. You don't have to punch it in right now, but we've got cosine of x in blue, sine of x over x in red, and 1 in black. So we can see our red function is kind of squeezed in between the other two, right, for that whole interval. All right, so all right, so we're squeezed in there. Now let's go ahead and look at a couple of these questions. It says, what's the limit as u approaches 0 of cosine of u? Well, let's try direct substitution. If we put 0 in there, cosine of 0 is what? Go back, that unit circle. It's going to haunt you forever, at least for the rest of this year. That's just 1, right? Right, cosine of 0. So 0 would be right here. Cosine is the x value, so cosine of 0 is 1. What's the limit as u approaches 0 of 1? Well, we just talked about that. Limit of a constant is the constant. So using this squeeze theorem, we should say that if both of those are 1 and this function's in between them, our limit has to be 1. Well, the reason we need to use the squeeze theorem is, look at what happens if we try direct substitution. If we put 0 in here, sine of 0, that's the y value right here, would be 0 over 0. Okay, well, we've seen a lot of problems that were 0 over 0 initially, but we did things to kind of figure out what the limit was. Those things that we've tried wouldn't work here. We can't factor, we can't multiply by the conjugate, multiply by a common denominator. None of that stuff's going to work here. But the squeeze theorem does. So that squeeze theorem is kind of giving us this limit. Helped us get this limit. We could also use the squeeze theorem to show that the reciprocal of this has the same limit. So the limit of u over sine of u would also be 1. We're not going to show that one, but it works similarly. All right, so these are two big ones that you need to remember, good ones to put on your My Review Guide.